The general features of the tangent graph. Unlike sine and cos where we call A the amplitude, this talks about some dilation. This would be the median, and n in this case determines the period, but the period for a tan graph is half that for sine and cos, so the period is going to equal pi divided by whatever n is. We have vertical asymptotes, and I'd work out where they are first before you draw the rest of the graph. So if I'm going to draw y equals tan of x, it's symmetrical about the line x equals 0, and if the period is going to equal pi divided by n, it's going to equal pi. So here at pi on 2, and over here at x equals negative pi on 2 are going to be my vertical asymptotes. I know that the tan of 0 is 0, and that pi on 4 is 1, and pi on 3 is root 3. So I end up with a curve that is approaching this vertical asymptote but never ever reaching it, and one that goes down there as well. So that's what the general rule is for one period. If I was to extend this graph to include two periods, another pi away from there, x equals 3 pi on 2, I would have another vertical asymptote, so that I'd also have a graph that looked like that in between, and that continues forever and ever and ever. So if I was to draw the graph of y equals 3 tan of 2x, then my period is going to be pi divided by n, which is 2. The 3 will have some stretching dilation effect. Okay, so to draw it, I know my period is pi on 2, so it's going to go over here to pi on 4 and over here to negative pi on 4, so that the distance between there and there is pi on 2, and that's what my curve is going to look like. I could continue it to go across here to the next one, which would be 3 pi on 4, and then that's what the curve is going to look like.